You're taking the SAT and you see this. What do you do? If your first instinct is to solve the quadratic, then you're wasting your time. Instead, we can use what is called Vieta's formula to turn this mess into a 15-second, one-step answer. And it's simpler than you think. So how does Vieta's formula actually work? Given any quadratic with coefficients a, b, and c, we know that it will have two roots, which we'll call r and s. Vieta's tells us two things. The sum of these roots is negative b over a, and the product of these roots is c over a. These two simple equations give us a clean relationship between the roots and coefficients that will always hold true. Notice here that if a question gives you a quadratic and asks for the sum or product of the roots, you don't actually need to solve for the roots themselves. You can just plug the coefficients straight into the formula. So, when would we actually use this? Fortunately for us, the SAT makes it very obvious when to use Vieta's, directly asking for the sum or product of the solutions. So let's look at the first problem again. Off the bat, we see that the question is asking for the product of the roots, so we should instantly think of Vieta's. Now, what is going on in this question? First off, don't let these variables scare you. The SAT loves to throw questions with many unknowns, and you oftentimes don't need to solve for their exact values. You might have realized by now that we can directly apply Vieta's here. Vieta's formula tells us that the product of the roots is c over a, or ab over 57 in our case. Quick note, it's extremely important to realize that these two a's are not the same. When using Vieta's formula, a represents the coefficient in front of x squared, or 57 here. It is not the same as the variable in this quadratic. Now back to our problem. We are told that KAB is equal to AB over 57. So K is just 1 over 57, giving us answer choice A. Notice how simple this was. All we had to do was recognize that we could apply Vieta's formula, and we got our answer without solving for A, B, or the actual roots of the quadratic. Let's try another one. Before we solve this, I will point out that College Board has labeled both of these questions as hard, advanced math problems. Basically, you won't see anything much harder on the actual test. Now take a few moments to pause the video and give this question a try. Once again, we are given a quadratic with a bunch of unknowns, but we don't need to worry about them yet. Our first step is to apply Vieta's formula, as the problem deals with the sum of solutions. Vieta's tells us our sum is negative b over a, or negative of negative 16a plus 4b over 64. Like last time, the b and a in our base formula are coefficients. They are not the variables in the quadratic. Simplifying this expression, we get 4a plus b over 16, and setting this equal to k times 4a plus b, we find that k is equal to 1 over 16. Once again, we solve this mess without solving for a, b, or any of the actual roots. And there you go. That is all you need to know about Vieta's for the SAT. It's a simple set of formulas that will save you valuable time on your test, bringing you one step closer to the 800. If you are interested in going a bit deeper, there is a general form that works for any degree polynomial, and also a beautiful proof of the formulas. It's a bit more advanced, but you can find all of this on the internet if you are curious. Also, feel free to comment what SAT math concepts you would like me to cover in future videos. And to those of you who are watching the day before the test, I wish you the best of luck. Trust the process.